a set of fine-grained Android permissions. So here, a policy, we say a policy is a set of rules, and the rules are fine-grained Android permission. So how we make the permission fine-grained? Normally the permissions are coarse-grained. Coarse-grained means you can just allow the permission or deny it. Fine-grained, I have made the permission fine-grained by introducing limitation based on time, folder location, or phone numbers. For example, the permission send SMS, you can allow it or block it in a coarse-grained system. But here, you can block the permission in a zone from, for example, 7 p.m. to 9 a.m. to a set of numbers. So if you apply this rule to a zone, then all the application cannot send SMS to the particular number from 7 p.m. to 9 a.m. So now a set of these rules creates a policy, and you can create multiple policies and apply to different zones. So what DMS can do, it can create, edit, delete those policies, move applications from one zone to another. So in each security mode, it can apply these policies based on the configuration file automatically to suit the security needs of that particular mode. This is the architecture of DMS. DMS is implemented as a part of the framework where also Droid is implemented. So it takes the context values from the Flamingo manager, which is a system application implemented also as a part of the system. So from the system, it gets the context values, and using the Droid manager, it configures the fine-grained permissions. In addition, it has a number of component and framework groups to implement the restrictions. We have implemented 3 restrictions. The first is the IPC restriction, or the inter-process communication restriction. Inter-process communication restriction means we can restrict communication between applications or applications in zones. If we want to restrict communication between certain applications in certain mode. There is a file access restriction, where if the restriction is on, you can block accesses to files in certain mode. As an example, say in your home, you took some pictures, and if another mode, the file access restriction is on, then in that mode, no application can access those pictures because it is created in a different mode. And lastly, we have a suggestive system, the permission verification system, where we have used web mining and machine learning to detect the anomalous permission requests and suspicious applications. I'll tell about the details in the next slides. First, the IPC restriction. What we have done in Android, all the communications are done using the binder library, and we call these messages intent. So there is an intent firewall in Android framework, and we have implemented a hook there, and we can monitor each intent. And before allowing any intent, we check the security policies there, and if communication between 2 zones are restricted, then we can drop the message. For example, if in a certain mode, you want to restrict communication between applications in the restricted zone, that is, the suspicious applications are there, then all the communications they want to make to another application will be blocked. The file access restriction, we have implemented using the SD card file system. In Android, the SD card file system is actually implemented using the Fuse library, which emulates a FAT-like file system on top of the ext4 file system. So what we have done now, when the file system is creating any file, it stores the more information in the extended attributes of the file. And whenever we access any file, it checks whether this file access restriction is on, and if it is on, it checks whether the current mode matches with the file creation mode. And if the mode doesn't match, it can deny the access. Lastly, the permission verification system. As I said, we use web mining. That is, we mine the Google Play and the VirusTotal website. And for thousands of applications, we mine their permission and reviews and create clusters of categories. So in each category, if an application asks a permission, which is actually anomalous in that category, then we can block the permission and notify the user that some application is asking a suspicious permission. For example, say a note-taking app is asking for microphone permission. So if asking the microphone permission is not common in note-taking apps, then it will generate this notification to the user. The feature we have used in the machine learning here in the permission verification system, in each category the permissions and the review score. And for the review score calculation, we have used this formula where S is the review score from the actual app market and Q is the number of review count to negate the bias of review count. So, for example, one review of 5 and like millions review of 3.9. This is an example of the configuration file that vendors can create for general users. So in the configuration language, you can describe the switching condition, when to switch the mode, and how to configure the zones and applications and policies, and the restrictions. For example, the network restriction or file access restriction, and things like that. To evaluate our tool, we first show the result of the permission verification system. Here I have used around 15,000 applications from the personalization category, and I have seen that in this type of work, the anomaly detection, the random forest algorithm performs acceptably. Here also we can see for these 15,000 applications, the random forest has 85% precision and recall, which means in 85% of the cases, we can detect the suspicious permissions and applications and notify the user. And as I say, we are trying to improve the existing scenario, and something is better than nothing. So at least to notify user that some application is behaving abnormally. Functionality, to address the functionality, we have moved the phone from one context to another, for example, our home, our office, outdoor, and we have seen that from the values of Flamingo, it can switch to different security modes successfully and apply the policies, and no applications were crashed during any mode switch. We want to also show that introducing these operating system components to improve security, we are not introducing actually overhead. So here I have shown that DMS has a very negligible overhead. First, this is the result score of a benchmarking app, Antutu benchmark, that is available from the market. And as you can see, the score differences are not actually very significant. In fact, in our experiment, we have found our DMS is scored a bit high than the stock image, because I have used OpenGApps, which has less number of Google services running. So, but the stock image has many Google services. So, but it is an indication that introducing some operating system components that perform not very resource-hungry operations will not be noticeable to the user, and smartphone resources are actually improving day by day. And the SD card file system. What we have found that up to 100 files, the access the delay in access will not be noticeable by the user. But more than 100 file accessing that many files in smartphones in real life is not common. So in our opinion, to implement this extended security, it will be acceptable by user. Portability of our tool, to implement the Zone Droid, we have used the permission mechanism of Android that was introduced in version 6.0. To apply our patch, the Android version need to be 6.0 and above. Lastly, the security analysis. So what kind of scenario we can improve using our tool for general users? Like the risk are eavesdropping, like malware can eavesdrop our call, SMS, or tap our meeting, or steal files in our SD card, like our photos. They can log or create profile from location history, or our touch or tap. Also, there's a risk of service misuse, like using the billions of smartphones as attacker of click fraud, distributed denial of service if botnets can control those devices. So this kind of sensory malware that tries to access the sensors and misuse, we can control them using fine-grained permission.